Good morning, everybody. It's a pleasure for us to have you all here for this webinar series which the Puducherry Climate Change Cell is organizing on climate change issues facing us. We are all in an unprecedented time facing large threat of corona epidemic. But one thing we should not forget is that there is a larger threat in the form of climate change, which we are facing, and the consequences are expected to be severe in the coming years. So we should be prepared to mitigate and adapt to climate change also. So in this context, we have started organizing the series of webinar. And today we have Dr. Divya Dutt and Dr. Suchi Badwal with us. I welcome them. I welcome all the government officials who are here and the officials from the climate change cells from various parts of the countries, from various states and union territories who are here. I also welcome the environment, and also my co-staffs who are present here. Thank you all for joining us. I would request my senior scientific officer, Dr. Sagai Alfred, to give his keynote address.
Hello, am I audible?
Yes, sir.
Okay. Happy morning to all of you, and really happy to invite UNEP, Kerry, as well as nodal officers of all the stakeholder departments, as well as all the participants who are participating in this mainstreaming climate change into development policies and strategies webinar series. Just happy to inform that the Puducherry Climate Change Cell is functioning under the Department of Science, Technology and Environment, which is being supported by Department of Science and Technology, Government of India, under the National Mission for Strategic Knowledge on Climate Change. Since the inception of this cell, that is the Puducherry Climate Change Cell, the main objective is for framing and implementation of the State Action Plan on Climate Change, as well as to conduct climate change research and to create more of public awareness about climate change in the Union Territory of Puducherry. The State Action Plan on Climate Change for UT of Puducherry was framed in the year 2014, and the same SAPCC as of now is under revision at present. Almost we are having 27 line departments as stakeholders with the nodal officers from each department for framing and implementing projects, which includes mitigation and adaptation strategies for making the Union Territory of Puducherry more resilient to the rising climatic issues. Also to inculcate better climate change perspective into the existing and the proposed projects being carried out by various stakeholders, departments or online departments, and to streamline their activities and the projects carried out by the line departments more appropriately towards the climate change perspective. It is also proposed to mainstream the idea of climate change into the policies and strategies of all the line departments that are doing various projects. With this in focus, we have planned this webinar series for the conduct of mainstreaming climate change into development policies and strategies. And in the long run, it will help all the line departments as well as the stakeholders to come out with proper strategies to be adapted for making reducing the climate change pressures and stress. At the outset, I would also like to welcome the eminent speakers, Dr. Divya Dutt, expert from the United Nations Environment Program, UNEP India, who is at New Delhi, and Dr. Sruchi Badwal, expert from the Energy Research Institute, New Delhi, who kindly consented and who is going to deliver the lectures on the above said topic. And a request to all the participants for better flow of data. I think you will also all agree. One thing is to mute the mic and to close the video for better flow of data. I request all to do this, please. I hand over the platform to the environmental engineer for further lectures.
Thank you, sir. Thank you so much for your address. I would now request Dr. Divya Dutt to begin this webinar presentation on mainstreaming climate change. Dr. Divya Dutt has been associated with us in the revision of State Action Plan for Climate Change as a technical partner. She holds more than 20 years of experience in policy research aspects related to environment and climate change and has been a member of various committees of the central government. She was a member of the Finance Commission on environment-related policy matters in the 13th Finance Commission. And she has been a member of the Ministry of Environment and Forest committees related to climate change and negotiations related to climate change. We are very proud to have her and to listen to her on her views about the mainstreaming of climate change into the government policies and developmental strategies. We welcome her to give her presentation.
Thank you very much, Mr. Kalamegam, and my sincere thanks to the Climate Change Cell of Puducherry for inviting me and the United Nations Environment Program, not just to this webinar, but also making us a partner in your very commendable initiatives to address climate change. I visited the Union Territory last year, and I was very impressed with the kind of motivation and the ideas and the ambition that different departments had to address climate change and to mainstream climate change issues in their sectoral policies. And we are very, very happy to be associated with the State Action Plan on Climate Change, where we are taking a slightly different course. We are not only doing what we are required to do as per the the guidelines of the Ministry of Environment and Forests. We're trying to go a step ahead and also see if there are a few sectors that can be taken up in more detail, the priority sectors where the climate change agenda and interventions can actually be mainstreamed. So this is a very timely and topical discussion. And I would say that Puducherry has actually already taken the lead in mainstreaming. What I'm going to do today, and I'm also joined by my colleague Sruchi Badwal, who's at the Energy Resources Institute in New Delhi. And between the two of us, we want to give you an overview of the whole climate change discussion as it stands today globally. both from the mitigation perspective and the adaptation perspective, as well as what the science of climate change is telling us with respect to the changes in various climatic parameters, but also the impacts of climate change. So we will be touching on the science, on the mitigation, as well as the adaptation, but everything from a global perspective. We'll try and give some examples here and there from India, but we know this is the first in a series of webinars, and there will be more sectoral, India-focused, even Puducherry-focused discussion later. So we thought that this first webinar could focus more on the global picture and give a global idea on the spectrum of issues around climate change. So that's how this presentation is structured. I'm trying to share my screen with you, and I hope I'm able to do that. It says there is an error while screen sharing, so I'm going to try again. Are you all able to see my screen?
Oh, yes, madam.
Yes, ma'am.
Okay, great. So I thought it'll be useful to start by, giving an idea of the 4 numbers that, if we look at the whole climate change issue globally, these are the 4 numbers that we should be familiar with. And in some sense, these 4 numbers hold the fate of so many in balance because of kind of impacts climate change is already having and will have in future. So the first number that we need to be very aware of is 1.5 degrees Celsius. And this is the number that scientists are telling us that we must try and restrict the increase in temperature with respect to the pre-industrial times too. And while there will still be climate change and climate impacts at 1.5 degrees, this is the level that scientists tell us will be associated with less devastating impacts than if we were to go higher than 1.5. In fact, for every fraction of additional, not just degree, but every fraction of additional warming beyond 1.5 degrees will have unprecedented and very uncertain, unknown, we don't know which direction things can go, and certainly very expensive impacts. So 1.5 degrees is the number that as a global community, we ought to be aspiring towards. It'll be useful to know that we're already at around 1.1. So really, we don't really have that much of a window in terms of time. We really have no time, and the action must start at all levels immediately. It's already quite late. The next big number is 25 gigatons. Now, this is the number that we need to limit emissions to if we are to stay within 1.5 degrees. So, and by 2030, we have to have emissions of only about 25 gigatons if we are to achieve the 1.5 degree centigrade target by the end of the century. However, the next number, which is almost the double of 25, actually more than double, is where we are headed. So if you look at today's emissions, then this is the number we are likely to reach by 2030, over twice of what we should be if we are to stay within 1.5 degrees. And this means that we collectively as a global community need to reduce emissions by 7.6% annually if we are to change this trajectory from 56 to 25. Now, why is 1.5 degrees important? Suruchi will talk a little bit more about the impacts, so I won't dwell on it, but I just wanted to, because I flagged this number, I wanted to highlight why this number is so important. So the IPCC has done some assessment of 1.5 degrees versus 2 degrees. And these are some of the things that they've pointed out. There is a lot more, but these are just a few indicators. So at 1.5 degrees, we are already estimating that 70% of all our coral reefs will die. At 2%, virtually all reefs globally will be lost. In terms of habitat for various species, and here we're talking about insects which are vital for pollination, half of their habitat is likely to be lost by 1.5 degrees already. But this will become twice as likely at 2 degrees Celsius. Similarly, the probability that the Arctic is bare of ice, completely bare of ice in the summer, has a chance of once per century at 1.5, and this will become once a decade at 2 degrees. The number of people who are likely to be affected by sea level rise will increase dramatically at 2 degrees as compared to 1.5 degrees. And sea level rise itself is expected to be 100 centimeters higher at 2 degrees. And along with this is the fact that the frequency and intensity of various extreme events, including droughts, storms, and other extreme weather events, which we're already witnessing, and you can see some images here, are likely to intensify much more at temperatures above 1.5 degrees. So this is why science is telling us that we really have to go all out to try and stay within 1.5 degrees. However, we are actually on the brink of missing the 1.5 degrees Celsius opportunity. Now, if you look at this graph, it looks a little complicated, but actually it's not. If you see the two red lines on top. So basically, first let me give you a little background. This is from UNEP's Emissions Gap report. And every year, UNEP brings out this Emissions Gap report to look at what is the gap in 2030 in terms of where we are headed on emissions and where we need to be if we want to be at 1.5 or even at 2 degrees. And we look at 4 scenarios. One is the baseline scenario, which is just a projection of 2005 trends, because that's when this discussion started. Then you have a current policy scenario, which takes into account all the policies that are currently in place, but assumes that no additional measures will be undertaken. It then has 2 scenarios that are linked to the nationally determined contributions, the NDCs, which were the commitments that countries made at the Paris Agreement in 2015 for voluntarily reducing their emissions. These commitments were of 2 kinds: unconditional, which countries said they would do anyway without any conditions attached, and there were conditional commitments which countries said they would make provided other countries, like India made some commitments but said that this would be possible only if it had additional financial or technology transfers from the developed countries. So certain commitments were conditional, certain were unconditional. So if you look at this graph, what it is showing is that whether you take the conditional or the unconditional commitments, you are headed up. Those are the red lines which are upward sloping. And you are seeing that we're actually, as we had said earlier, you're headed towards about 56 gigatons, which is an upward slope. Whereas if you look at what is required for 2 degrees and 1.5 degrees, it's a sharp fall in emissions. And the emissions gap, which is the red and orange bars, the bars which are to the right of the graph, are actually widening over time. So basically what this graph is showing, that even with the commitments at Paris, if we take the unconditional commitments, we are headed at a 3.2 degree. I'm sorry, that should not be percentage. That's a 3.2 degree temperature increase. We are headed to a 3.2 temperature degrees. And the impact of this is really unimaginable. We can't even imagine the kind of impacts that this is going to have on all of us and on the smallest aspects of our lives. And Suruchi will talk a little bit more about these impacts, so I'll leave that for now. But the larger point is that the commitments that we have made are not enough even for a 2 degree scenario, and we are really headed for a very high temperature increase by the end of this century. We are on the brink of missing this opportunity. Why? Because the last decade, that is the decade of 2010 to 20, has really in some sense been a lost decade. We've been able to make no real change in the global emissions pathway. As you saw in the previous graph, we are on an upward trajectory. And while there have been climate policies in countries, these have been too small to offset the impact of key drivers, which are economic growth, population growth, and the various sort of accompanying trends that come with the growth of economies and populations. What this also means is that every day that we delay, the steeper and more difficult the cuts in emissions are going to be. So to give you an idea, what UNEP in its emission gap report finds, that 10 years ago, if countries had heeded to the science we would have had to reduce emissions by 3.3% each year. Today, we need to reduce by 7.6% each year. And even the most ambitious, like I showed in the previous slide, even the most ambitious climate plans are far short of this. We today need a 5-fold increase in collective ambition and commitments as compared to what we've done at Paris. If we delay further, then what is expected is that by 2025, we will need cuts of 15% each year. And this will virtually make the 1.5 degree target impossible. So we have a really small window to get our act together. If we are to reach 1.5, but very soon it's going to be out of reach for us, because the kind of emission reductions that will be required and the costs that will be associated with these emission reductions are going to be enormous. But this also means the delayed action is not only going to make further emission reduction difficult, but it's going to make the cost of impacts very, very expensive, very, very high. So whether it is adaptation through sea defenses or measures to increase our food security, which is going to be affected severely because of climate change impacts, or the impacts on making our infrastructure more resilient to the impacts of climate change, all this is going to become more and more costly. So the bottom line is that unless we have new and much more enhanced nationally determined contributions, which are agreed to by this year was when we were going to have the 26 party, the Conference of Parties to the UNFCCC, where the countries were expected to put forth their new commitments, their new NDCs, but because of the virus, it hasn't happened. It's going to happen next year. Unless these commitments are stretched, even by countries which are doing well, which are meeting their commitments, countries like India, we all need to stretch these commitments, because with the current commitments, we are nowhere near the 1.5 degree target. Now, what are countries doing? It's not that countries are not doing anything. There are a number of countries and regions that are adopting ambitious goals, which are in line with the transformation that is required. But clearly, the scale and pace of this transition is not sufficient. Many nations, like I said, are expected to strengthen their commitments by or at COP26 next year. It's encouraging that about 71 countries and 11 regions have already set long-term targets of net zero emissions, economy-wide targets of net zero carbon neutrality. However, these differ in scope, they differ in timing, and they differ in the degree to which they are legally binding. And the catch here is that this is countries which only account for 15% of the global emissions. The others, which account for about 85%, are still to make any similar economy-wide large commitments. Now, within this set of countries, if you look at the G20, which is a group of 19 countries, which includes India, plus the European Union, this set accounts for about 78% of all emissions. And therefore, theirs is the biggest opportunity to lead the world into a thriving future. Having said this, I would also like to state that the Paris Agreement actually recognizes that non-state and subnational actors, including state governments, are increasingly important. But the current mitigation impacts are poorly documented. We're only talking about mitigation impacts at the national level. It's important to start looking at what the impact of mitigation interventions are at the subnational level, because especially in federal countries like India, subnational governments and some subnational actors are going to play an increasingly important role when it comes to climate change mitigation. So going back to what's happening globally among the G20, if you look at the G20, it's the top 4 emitters are in that order: China, US, the EU, and India. And these 4 countries contributed to about 55% of the total emissions last year. This is if we exclude emissions from land use change. If we include emissions from land use change, basically deforestation, then Brazil is likely to emerge as the largest emitter. Now, if you look at the action, then as I said, there are countries especially in Europe, so UK and France, which have already passed legislation for carbon neutrality. There are other EU countries which are pursuing this objective and are likely to do this very soon. However, 15 of the 19 G20 members have no such targets. My graph is a little bigger, the map, so it's sort of taken away a little bit of the text. But essentially, the point being made here is that a small set of countries has actually, has taken up these initiatives, but we have a long way to go. China, which is the largest emitter globally, has among the most ambitious renewable energy policies. However, its emissions continue to grow. US, as we all know, is really dragging its feet and actually taking some steps backwards when it comes to national commitment. However, there are states and territories in the US which are very progressive, and several of these have actually passed legislation which have set goals such as for 100% clean energy by 2050. And even at the city level, so this really goes to show the importance of subnational actors. And I think US is a very good example of this, because even though the national government is being seen as a detractor, we can see that at the subnational, state and city level, there is a lot of ambition and a lot of progressive action. So there are over 100 cities in the US which have made 100% clean energy commitments. And there have also been some positive initiatives from industry because the cities are pushing them to do this. The EU is likely to meet its NDC targets, so is India. India also, even though it's the fourth largest emitter, it is still among, if you look at the per capita emissions, India is among the lowest in the G20 when it comes to per capita. However, the impacts that we're looking at globally are because of total emissions, and therefore, India is more and more getting pulled into this discussion of having to also look at its own aggregate emissions. Now, moving from emissions to where are the mitigation and mainstreaming opportunities? Now, what the foregoing discussion clearly shows that a piecemeal approach is not going to help. And we really have to see how we can mainstream climate change agenda, climate change action, climate change thinking into sectoral policies and sectoral thinking. And where are these opportunities most likely to show impacts? So if you look at this graph, it shows that if we are to take action on six sectors, and these are energy, which is the largest, industry, forestry, transport, agriculture, and buildings, this is really where our action should be focused. And if we are able to crack intervention in these sectors, we can really change the trajectory from going up to moving towards the 1.5 degree goal. Even it is noted that there are 6 areas: solar, wind, there is a little bit of disturbance. If everyone can mute their microphones, please. So even within these sectors, there are 6 areas: solar, wind, efficient appliances, efficient cars, afforestation, and arresting deforestation. These present a combined potential of up to 21 gigatons of CO2 equivalent by 2030, and will be sufficient to get us on a pathway to well below 2 degrees Celsius. So these are the areas where globally we need to be focusing our attention to. And the other good news is that while we will still need innovation, which is happening at very rapid scales in many parts of the world, to achieve full decarbonization, policies and technologies exist that can be very readily picked up and at reasonable cost adopted in different country contexts. So from the previous discussion, it's evident that the focus really has to be energy, because the carbon emissions from fossil fuel use in the energy sector and the industry sector dominate total GHG emissions. So decarbonizing energy supply and transport is going to hold the key to climate change mitigation. On the other hand, energy needs are actually projected to grow. We are expecting a 30% growth in energy needs by 2040 due to various factors. And therefore, while this growth so basically we'll have to look at how this growth itself can be made more reasonable through energy efficiency. So energy efficiency across the board, whether it comes to heating, cooling, appliances, lighting, various industrial processes, motors, transport, energy efficiency is going to be critically important. So one is efficiency to reduce the demand for energy. But on the other hand, moving more and more towards renewables when it comes to energy sources is going to hold the key to the solution that we are looking for. And with moving to renewables, we'll need interventions such as smarter and more flexible grids, and moving more and more applications to electricity. So basically, the point that is being made globally and in India is that we need to do two things. We need to move our electricity sector to more renewables, and we need to move more and more of our energy supply to electricity. So whether it is for cooking, whether it is for mobility, if we move from fossil fuels to electricity, and electricity in turn moves more and more to renewables, that's how we can break the dominance of fossil fuels in the whole emission portfolio that we have as of now. When it comes to renewables, renewables are already increasingly competitive, and we've also seen that in India, and globally for the 7th successive year, the net additional power generation capacity of renewable actually exceeds that of non-renewable sources. So means higher capacity enhancement has happened in renewables compared to non-renewable sources. And the growth rate in renewables have averaged 8 to 9% each year. However, there are still issues with the regulatory and policy frameworks, which will be the necessary preconditions. And we've seen this all too often in India, where due to the lack of consistent regulatory frameworks, there have been several setbacks, and the industry players have become more and more, or at least in some instances, they have lost confidence when it comes to investing in staying engaged in India in the renewable energy sector because of inconsistent policies in some areas of the country. So therefore, while renewables now have the potential, the technology exists to make renewables competitive with respect to conventional sources of energy, it's the backing of policies and regulatory frameworks that we will need to pay a lot of attention to. So basically what I'm doing now is, after giving you a global picture, focusing on a couple of things. So one was, this at a large level when it comes to electricity. And then the other issue, the second area which I wanted to touch on is cooling. Now, for a country like India, which is a tropical country where, we're already facing very high temperatures, cooling and the demand for energy for cooling is going to be a very important area that we have to consider. The cooling demand, as per the India Cooling Action Plan, the cooling demand in the country is expected to actually rise 8 times in the next few years. So we are looking at a significant increase in cooling demand, and most of this is going to be for electricity for space cooling. Now, why is cooling so important? Cooling is important not just from the space cooling perspective, but also, and for space cooling, I have a statistic here that by 2050, global demand for space cooling is going to triple. And this segment, only space cooling, is going to take up as much energy as currently consumed by China and India. So that is the amount of energy that is going to be required by the cooling sector. But it's not just space cooling. If you look at agriculture, cooling is going to have a huge impact on the sustainability of agriculture and our food security. We lose almost 1/3 of food that is produced globally because of, among other reasons, lack of cold storage. And it is often said that if the food sector was a country, it would be the 3rd or 4th largest emitter of carbon dioxide, because that is the amount of food, that is the amount of emissions that the sector is responsible for, both in terms of production as well as the whole supply chain. So every unit of food that you lose also means that there has been a huge carbon footprint that has actually not been put to any use. It's just wasted. right? And then there are other impacts on water use, on land degradation, on biodiversity, on, we've seen the impact of unsustainable use of chemicals on groundwater, on land productivity in India now, and the impact that it has had over the years on productivity of our agricultural systems. Anyway, but that's besides the point. Here we were looking at why cooling is important for agriculture, because it is estimated that about 1/3 of our food that is produced is being lost due to lack of cold storage. So from that perspective, cooling and energy use for cooling is going to be exceptionally important. The other area is vaccines. Globally, about 10% of newborns are not vaccinated. In India, if you look at India, which has among the largest immunization programs in the world, it is believed that about 25% of all our vaccines are wasted before they are used because of lack of cold storage. So cooling, especially in the context of India, where the demand for energy is rising, cooling is going to have a very important impact, and our interventions in cooling are going to have a very important impact. I have some graphs here which are from the India Cooling Action Plan, which is being applauded globally as one of its kind. And even the UN Secretary General has actually commended India for putting this plan, because it's been done in a very holistic manner, looking not just at the energy options, but also looking at how efficiency can be improved, how refrigerants can be, changed, because we're looking at moving away from the current refrigerants, which have a huge GHG potential. So there is a significant reduction potential, as you can see, in different scenarios that the India Cooling Action Plan has put together. And they have gone up to 2037, 38. And they have then said that with and without interventions, what are the likely changes in electricity, energy demand, in refrigerant demand that can be achieved if we have these proactive interventions. At the global level, what is found is that if we are able to phase down hydrofluorocarbons by 2100 under the Kigali Amendment to the Montreal Protocol, which is basically focused on refrigerants and moving away to climate-friendly refrigerants, this can reduce or achieve 0.5 degree of avoided warming. If we are able to integrate energy efficiency into this, which is what the India Cooling Action Plan also aims to do, this can double the climate benefits and will be equal to roughly 4 to 8 years of GHG emissions based on 2018 levels. So this is the kind of benefits that cooling as a sector can bring. And I'm highlighting this because in states across India, union territories across India, including Pondicherry, this is going to be a very important aspect in our development thinking and planning. The other issue I wanted to highlight very briefly, though this is more like a national issue, is coal. Now, coal is a very sensitive issue in India, but it's something that we need to start thinking about, which at the global level, the UN and other international agencies are focusing a lot on, while understanding the sensitivities of countries like India. But if you look at this graph, what it basically shows, so this is where we are. The second red band is where we are with respect to the 1.5 degrees. If you want to remain within the 1.5 degrees, and this is the second red band, the first red band right on top is where we have to be in terms of the 2 degrees. And if you look at where we are currently, which is the first bar, all sectors without coal, then you're already very close to 1.5 degrees. If I add to this emissions from existing coal plants, we've already reached 1.5 degrees. If we add to this emissions from coal plants under construction and coal plants that are planned, then you see we are already taking up a sizable portion of our emissions budget for a 2-degree target. So the point that is being made here is that if we continue with the current plans for coal, then the 1.5 degree target is going to be impossible. It's not going to be feasible. It may even make 2 degrees very difficult. It will take away a large share of the window that we have for 2 degrees. So really we need to start, as a first step, avoid any further lock-in through new coal plants, and then also start seeing how we can gradually phase out existing coal plants. Now, this transition, we understand from a social and political and economic perspective, is going to be extremely challenging for countries like India. And therefore, it needs to be done in a phased manner, and with the due consideration and balancing of impacts when it comes to livelihoods and energy prices and the impact that can have on the rest of the economy. So those are the issues that are already a lot under discussion even for India. And the fact that renewables have become so competitive and the government of India has been giving so much emphasis on renewables is extremely welcome. Though we have seen in the Atmanirbhar package, the package in response to the current pandemic, there has been a re-emphasis on coal, which is a little worrying. The coal sector, investments in coal sector are being opened up, it's being encouraged. So I think it's important for us to also keep this big picture while understanding the immediate needs of the country. It's important to look at the global picture and what this might lead to, because India is one of the largest coal users when it comes to electricity. I have only a couple of slides more, so I'll quickly go over those. The other issue in terms of mitigation that I wanted to highlight, which will be very relevant for even regions like Puducherry, is nature-based solutions when it comes to CO2 removal. Now, here we're talking about mitigation, but we also need to look at options that exist for removing the carbon dioxide, which is already in the atmosphere. And really, nature-based solutions are the only option that we have currently. The Emissions Gap report of 2017 actually estimated that if we can control deforestation, we can mitigate around 5 gigatons of CO2 equivalent annually, which is like a huge impact. So India, of course, prides itself in the fact that our area under forests has gone up. However, there are still some concerns about the quality of forests, the degradation of forests. So these are issues that we need to pay attention to, not just from the ecological perspective, the local impacts on biodiversity, but also the larger climate agenda. And let me at this stage also point out that the current pandemic, as you would all know, is a zoonotic disease, meaning that it has come from animals to humans. It is estimated that about 60% of all infectious diseases currently are zoonotic. And going forward, this is going to be 75%. So the bulk of all infectious diseases are going to come from animals more and more. And the reason why this is happening is because of habitat loss and illegal trade and a whole lot of things which are associated with injudicious cutting down of trees and forests and encroaching into the territory of other species, making us in turn more vulnerable to the vectors that they carry. So I think this pandemic has very clearly brought out the need to respect biodiversity, not just for the sake of a thriving planet, but also for our own immediate health and existence, actually. So these are some of the considerations that we have to that can be important when it comes to maintaining our forests, establishing new protected areas, using different types of measures which are regulatory to ensure conservation, but also looking at the option of different economic instruments like payment for ecosystem services, so that communities and regions that preserve forests can be compensated. And an important example here would be what the last few finance commissions have done. So to take the case of the 15th Finance Commission, they have, in the devolution criteria, they have set aside a weightage of 10% for dense forests. So this is in some sense compensation to forests. It's a payment for ecosystem services to those states which have preserved their forests in national and global interest. So we need to start looking at more of such instruments, perhaps even at a more local level within a state, within a region, of how we can encourage such payments to those as rewards for such action. And finally, also policies that are affecting policies to arrest activities or incentives that are responsible for deforestation. So whether it is cooking fuel, whether it is timber needs. So we need to look at how some of these sectoral policies can be changed and mainstream, again, nature-based solutions, nature-based thinking into these policies. I will end with this. This is really, I thought it'll be useful to also give you a picture. We've spoken about where we are globally and what's the seen globally in terms of emissions by country, emissions by sector. The emissions, GHG emissions by sector for the country as a whole actually very closely mirror what we saw globally. So if you look at the data that India has submitted in its second biennial update report to the UNFCCC, then the energy sector accounts for about 73% of India's total GHG emissions. This is followed by agriculture, 16%, followed by industrial processes and product use, and the waste sector. Within the energy sector, it is dominated by fossil fuel combustion, which comprises energy and power industry, manufacturing, transport, and others. And within energy, about 95% of emissions was actually from electricity production. So thus, if you put it all together, once again, we have the same picture that electricity production accounts for about over 40% of the entire GHG emissions from all sectors in 2014. So we really have to see how we can move, and this is the point I wanted to make at the end, that how can we decarbonize electricity is going to be key, and at the same time, how we can move as many applications as possible from other fuels to electricity, especially transport. We can move more and more towards e-mobility while changing our electricity profile towards renewables. I think that is the way for us to mainstream climate change mitigation as we move forward. So I will stop at that, but we can continue some of this discussion in the question and answers. So back to you, Mr. Kalmegam. Thank you very much for this opportunity once again.
Thank you very much for your very informative speech on this topic with relationship to the mitigation aspects of climate change and how to mainstream the various opportunities for mainstreaming mitigation strategies into the developmental actions of at local level as well as national level. That was a wonderful speech from your part. Now, I would like to invite Dr. Suruchi Badwal from TERI, who is an expert on climate change impacts, vulnerability, and adaptation strategies. TERI is also associated with us in revision of the State Action Plan on Climate Change. And Ms. Suruchi Badwal is a senior fellow on the Earth Science and Climate Change division of TERI. I request her to start her presentation.
Thank you very much, sir. Am I audible?
Yes.
Yeah, okay. So thank you very much for giving me this opportunity. I would like to thank the government of Puducherry, Department of Science and Technology, and the UN Environment to invite me in for this webinar. Divya's excellent presentation covering almost all aspects of mitigation, as well as touching on some parts of the science and the impacts. My presentation is largely focusing on what is the science behind climate change, basically covering up topics related to the impacts of climate change, vulnerabilities, and adaptation. So most of the work that I'm basically presenting in my slides is from the 5th assessment report of the IPCC. And there are some examples that I've taken in the Indian context from work that TERI has done in different states, basically to give it an Indian flavor. There are examples at the global scale, which have been taken from the IPCC, but just to kind of link some of the findings that we have in the Indian context, I've just taken some examples in the flow of my presentation. So to begin with, basically, whenever we have discussions with policymakers across the country, one of the foremost questions that we face and basically are asked is related to the certainty of the science of climate change that is being discussed. And as scientists, we basically show this particular slide, to most of our stakeholders to basically bring home the fact that while there are projections that are being made into the future, and therefore and that's based on certain assumptions, we are sure of the nature of the changes that we are talking about, because we've already experienced a certain degree of change over the 20th century. Now, the IPCC basically summarizes that global mean temperatures have already risen by 0.7 degrees centigrade in the 20th century. So this is something we've already observed, and it's not being basically forecasted or projected into the future. We've also experienced a rise in sea level globally. This may vary regionally, so across different parts of the world, the rate of change may vary, but globally there's already been a 0.1 to 0.2 meter rise in sea levels across different parts of the world. There's also a decrease in snow cover and ice extent that has been observed all across the world. There's a 10% reduction in snow cover since 1960s. There's been a 10 to 15% reduction in the spring-summer ice extent. And of course, there's a lot of impact that we now observe on the glaciers and the reduction of glacial mass in many parts of the world. 1990s and post-1990s, every decade that is basically is passing is a tide warmer than we have basically observed in the past. So of course, these changes have already been observed, and therefore the certainty to talk about the changes in the context of the future also, wherein of course there are some assumptions that are basically made. I just want to check if my slide has changed. Hello?
We had a fourth slide, 21st century projections.
So this is okay. So this is basically on the 21st century projections, and here, while we
Ruchi, can you put your slide on slideshow?
Sweat. Okay. 1 second. Is it on slideshow now?
Yeah.
Okay. So yeah. So while there have been changes observed in the 20th century, scientists predict and project changes in the 21st century in the same manner that have been observed over the 20th century. But the rate at which these changes are predicted and projected are far more higher compared to that we have observed in the 20th century. And the reason for it to be far more faster, rapid than the 20th century is because the concentrations of greenhouse gases, and it links to Divya's presentation, wherein basically that has been increasing over time and accumulating in the atmosphere, and therefore the rate of changes that we're expecting over the 21st century is far more higher as compared to the 20th century. Now, with the various models that are run to see what kind of changes are likely given the increase in the greenhouse gas concentrations in the atmosphere, the projections basically do not hold much of a promise. Divya was indicating at the 1.5 degrees Celsius target, and of course she also mentioned that 1.1 degrees somewhere we already stand globally. Until now, if you were to look at the last 120 years. But in the future, we are basically having different assumptions on the basis of which we're looking at the changes. And the projections basically say that temperatures could anywhere lie between a 1.1 to 6.4 degrees centigrade, depending on the various development trajectories that we basically choose to move forward with. And I will come to the different scenarios and how have we arrived at the 1.1 to 6.4 degrees centigrade. Similarly, given the rate of changes in the temperature, there are other parameters that are closely associated with the warming that we experience. Therefore, increase in mean sea level is expected to be to the range of 0.09 to 0.88 meters, which is also likely to vary regionally across different parts of the world. It may be higher in some parts of the world, it may be lower in some parts of the world, but this is the rate of change right now we're expecting to be experienced in different parts of the world. And of course, this is because the temperatures are rising. This is likely to lead to decrease in snow cover and sea ice extent. We are talking about the Arctic and the Antarctic melting at a very rapid pace, but also coming back home, all our mountains which are snow-capped and glaciers which are there in the Himalayas are also likely to get affected because of these changes that we're talking about. And of course, this will have implications on river systems and river flows, which are dependent on these sources for their flows to be maintained throughout the year. Therefore, the perennial nature of many of these river systems are also likely to get affected. Now, these are the scenarios on the basis of which those numbers have been arrived at. If you look at the blue line and the red line that we have in front of us in the figure, the blue line is the lower trajectory of growth and the red line is basically the higher trajectory of growth. So moving on from 1950, if you see, there's a certain trajectory of development that we have been following world over. And that line basically follows that, and then suddenly throwing it into the future based on the path that we choose, whether we choose a greener path of development vis-a-vis a much more fossil fuel intensive consumerist path of development, is where we will basically lie in future in terms of emissions that we would basically contribute to, and as a result contribute to the increase in the greenhouse gas concentrations in the atmosphere, and as a result perturb the climate system and result in changes in temperatures, rainfall patterns, and many other things that are associated with. Now, the RCP is basically representative concentration pathways, which is to do with the greenhouse gas concentration and the rate of change that is likely to happen in future time periods based on the development trajectories that we choose, whether we are going towards a greener path of development wherein we are moving towards more renewables, we are moving towards more energy efficient modes of development, and we are basically making sure that we are protecting our environment. There's lesser degree of deforestation, there are more protected areas, and there's more sequestration that's happening of carbon dioxide and greenhouse gases. So that's the blue line trajectory where countries will have to shift majorly towards that direction of development, and therefore it will result, it may then result in a lesser degree of perturbation of the climate system. But in case we are following the red line, which is basically still using our fossil fuels, a lot of emissions from the transportation sector, as Divya was also hinting at, cooling requirements that may increase with the rising temperatures, may lead us towards the red path with more degree of emissions and concentration, and therefore basically higher level of changes that we would expect. And right now, just to bring home the fact, we are moving towards the red line of development. There are international treaties, agreements in place. We are still to see what kind of actions that would lead to be able to help us move below the red trajectory that we have over here to at least come down to the levels of change that we are expecting right now. So this is basically the different scenarios. There is RCP 2.6, which is a modest scenario, the blue line. The light blue is a 4.5, which is a slightly above than the 2.6 scenario. And then there's a 6 scenario, which is it's increasing further on. And then RCP 8.5 is the most extreme scenario development trajectory that we may follow, and therefore result in terms of perturbation of the system. Now, it's just not about temperatures increasing. Actually, once the temperatures increase, there are a whole lot of changes that we're going to expect in all other things which are, in the climate system. So with the temperatures increasing, you will see changes in rainfall patterns because the water holding capacity of the atmosphere would change, and therefore there would be more evapotranspiration that would be basically experienced, which will lead to more cloud formation and more rainfall. Now, whether this rain will fall on land or whether it will fall in the ocean space, basically is for time to say. But of course, these changes in the climate system will be observed, and they're all interconnected. Of course, how humidity levels would change, and of course, all this has to do with the timing and frequency of different kinds of events, which very closely relate to the occurrence of droughts and floods and flash floods in certain parts of the world and the country. So they're all so with one particular a parameter changing, there are a whole lot of changes that you would experience in the entire system, which has everything to do with your functioning on a day-to-day basis. So this is a global picture of the rate of change we are basically going to experience under the two scenarios. So now the examples that I have are from the two extreme scenarios that I was showing in the trajectory before. So it's RCP 2.6 and RCP 8.5. It's the modest scenario and the extreme scenario. And if you see across the world, these are the kind of changes, degree of changes that we will be experiencing up till 2100. So now until 2100, and what kind of changes are we going to experience? Easily in a modest scenario, we will be seeing changes in temperatures to the tune of 2 degrees centigrade, and India is very much in the same rate of change that other parts of the world are going to experience. So about 2 degrees centigrade, 1.5 to 2 degrees centigrade, and that's where Divya was basically hinting at. It's very important to contain ourselves at that level, because there are huge implications with the rise in temperatures that we are likely to observe once we cross the 1.5 degrees Celsius. Now let's look at the other figure, which is the much towards the right, which is a much redder figure, which basically tells us that the rate of change is going to easily lie between a 5 to 11 degrees centigrade in certain parts of the world. Now, this is a very scary picture, at least for people like me who work in the climate science space, basically saying that the rate of change is going to be so high that many parts of the world are going to experience as high as 7 to 11 degrees Celsius increase, and India is somewhere between the 5 to 7 degrees Celsius. Now, 5 to 7 above, something like 46 and 47 degrees centigrade temperature in the summers is basically meaning that we will have some temperatures to the tune of some 52, 54 degrees centigrade in many parts of the country during peak summers, and that's pretty high. And so ideally, the rate of change at the higher end of the spectrum is going to be so high that it will have huge implications in many parts of the world, whether it's for energy demands for cooling, or whether it's going to be on health issues that may crop up, etc. And therefore, there are huge concerns with the extreme scenario that we are looking at in terms of development. And right now, we are somewhere heading towards the extreme scenario, but if there are corrective measures taken and looked into, maybe we as a world could move towards a much more modest scenario of change in future, and that's something for the world to decide. This is a picture basically talking about changes in rainfall patterns that are likely in future time periods. Now, in all the scenarios, whether it's a modest scenario, which is the first figure, and the last figure, which is towards the lower side on the right-hand side, the changes for India are positive in the sense there's going to be more rain in India in future time periods. Now, more rain is a good thing, but it's also a bad thing. And of course, if we are able to manage the more amount of rainfall that we are likely to receive and channelize it in a good manner, then I think we will be able to handle the situation. But when we are talking about increase in precipitation patterns in places where we are not well prepared to channelize, then it largely leads to situations of flooding. And that is what we are experiencing nowadays. When you yet and again, every monsoons, you keep hearing about large parts of the country getting flooded and unprepared for heavy precipitation events. So this is something we're going to experience again and again and again and again. And I think the country needs to prepare itself much better for the coming increase in rains across different parts of the country. And this relates to the previous slide saying, so this basically means more rain means more floods, more waterlogging situations in different parts of the country, but also it means droughts in certain parts of the country, water scarcity in certain parts of the country, because the distribution of rainfall, as you have already seen, even during the normal times, basically is not uniform across the country. So when it is rained much more in a certain part of the country, the other parts basically are devoid of rain, and therefore you may observe areas which are waterlogged, and on the other hand there would be areas which actually haven't received enough rainfall, not even reaching their normals, and therefore experiencing drought. So you're going to create situations of extremes across the country, spatially speaking, and therefore you will need to see how you would manage these situations over future time periods. Now this is related to sea level rise. The rate of sea level is increasing. This is in observed time periods 1960s to 2003 and 1993 to 2003. The rate of change, if you see over the 30-year period or 40-year period from 1960s to 2003, vis-a-vis the between 1993 to 2003, which is just a decade, has it has actually doubled. So what we were observing in 3 decades, we are now observing in a decade, and it has basically doubled in a decade. So the rate of change, as I was also driving home the fact before, is actually increasing in the 21st century, and there are obvious reasons for it, because the concentrations have increased tremendously over the period, and therefore they're causing drastic changes in the system. This is basically the future projections for sea level rise, and as I said, it's basically going to be to the tune of 0.8 meters to 1 meters in terms of the high end scenario, and we may lie anywhere. And of course, regionally speaking, we do not have very good projections for the Indian coastline so far to look at what is the direction or rate of change along our coastline. But of course, going with the global pictures, and we are not out of the world, we can expect that we will be somewhere around the 0.6 to 0.8 meters and 1 meter rise that we are basically likely to experience. This is again a slide on the sea levels and the rates. I will skip this slide and get on to this. Now, this was a study basically compiled by the IPCC, where they tried to look at different countries and which have coastlines, to see if there was certain degree of rise in the sea level, what kind of an impact would it create for different countries. Now, I'm just picking the India row to say 100 centimeter rise could easily lead to potential land loss in India to the tune of 5,763 square kilometers, which is huge amount of land. Basically a 0.4% land loss, affect about 7.1 million people, and this is the 2001 statistics, and this would easily be, the numbers would have scaled up tremendously by now, which is to the tune of 0.8%. So there are countries other than us who are far greatly affected, but that doesn't mean that India doesn't need to be concerned about these losses that we are going to experience in coastal areas. And of course, loss to land is loss to economy as well of a particular region, and all these correlations that then happen, following on. So therefore, there are huge losses that we are expecting. This is a 20-year-old figure, and there are no further assessments of this kind which has been compiled to be able to show what is likely to be the degree of loss. But just registering it in our minds that the losses are going to be huge. It's not just about the sea rising, but the land that's going to get lost, the infrastructure damage that it's going to cause, plus the people who are living around the coastlines who are going to get affected. This is basically the trajectory that I was showing you again and again before, that there's a low-end trajectory, development trajectory, there's a high-end development trajectory. We can lie anywhere from the low to high. And basically, right now we are on the high-end trajectory in terms of development, and therefore the emissions and the changes that we are expecting. Now, in many cases, we basically face this question from policymakers saying that, so, because there's an uncertainty surrounding these projections and the assumptions behind, So, because any decision taken by policymakers basically would, relate to investments that need to be made, etc. So what do we plan against if we, for mitigation and adaptation to climate change? So the best answer that scientists can basically give right now is that, okay, so we definitely know we are not going towards the low end development trajectory, and we are towards the high end development trajectory. We do not want to invest so much in these actions to the tune of a high end scenario. Then at least we should be planning for a best estimate scenario, which is the middle path scenario, the mid estimate scenario, to be able to respond to the risks that we are likely to face in future time periods, so that if we are over time realize that we are going to be somewhere lower in the spectrum, we would have planned for it. But if we are somewhere higher in the spectrum, we can revise our development plans and again try to adjust to the higher end spectrum. So at least it's not a no response case, but at least some degree of response, so that we're not waiting for disaster to strike us and then respond to the changes that we are likely to face. So therefore, concluding this section saying that while human-induced climate change has the potential to trigger large-scale changes in Earth's systems that could have severe consequences at regional or global scales, the probabilities of triggering such events, as understood, is though limited, should not be ignored, and given this, considering the severity of the consequences of such events. So therefore, while we know that these systems are getting perturbed, I think, and we have a limited understanding of these areas, in terms of the projections, the way they have been projected based on different development trajectories, in no way can we ignore them, because the consequences are likely to be very severe. And this is basically saying, even if today we decide to stop the changes that we are basically contributing to by limiting the greenhouse gas emissions and the CO2 that we are releasing into the atmosphere, we have all perturbed the atmospheric system already to the tune that it's going to take, in certain cases, many decades for the system to come back to normalcy. And in certain cases, it's going to take centuries to millennia for systems to come back to normalcy. Now, a very simple example is of oceans and seas, where the heating has already been happening. The temperatures, ocean temperatures and sea temperatures have been rising. And slowly, this increase in temperature has been absorbed in the deeper levels of the seas and the oceans as well. And therefore, to be able to come back to what they were maybe 30 years back or 60 years back in terms of, the temperatures and the environment that was there in the context of marine systems, it's going to take centuries and millennium in certain cases for coming back to what the way they were before. So these are time scales, because every greenhouse gas admitted into the atmosphere has a certain time scale, a time period in which it basically, it's the residence time period of that particular gas in the atmosphere. So carbon dioxide, easily the time period is between 100 to 150 years. And 1 unit of carbon dioxide basically released today, it will remain in the atmosphere for that particular period of time. So therefore, you already perturbed the system for 150 years with the emissions you did today. And so similarly, when we have been emitting in the past, all those units of emissions that have happened basically have perturbed systems over different lifetimes of different greenhouse gases that have been released into the atmosphere. This is an India picture of projection of the rainfall for future time periods. And I've already told you that India is going to experience an increase in the rainfall. This is an older assessment that has been done, but the newer findings basically in summary tell that India is going to experience increase in rainfall over future time periods. Of course, the distribution of it is likely to vary, and it's not that the whole of India is going to experience, a high rainfall, but it may be the country, and different parts of the country may experience extremes in forms of floods, droughts, and water scarcity. This is temperature rise. If you see, the temperatures are also going to rise, drastically to the tune of, 3.5 to 4 degrees Celsius in the extreme scenario that basically we are observing. But ideally, in many places, it's going to be higher than the 4 degree also if we in case of the extreme scenario. Now, this is just an assessment that Terry had done. So these assessments were from Terry, actually, from a previous study that we've done. But ideally, the signals are increase in temperatures, increase in rainfall. Now, this is for the Indo-Gangetic plains. This is South Asia. This is the Himalayan region that basically you're seeing. And these are assessments done in a certain study that we were carrying out, the last 5 to 7 years back, where we were looking at changes in temperature. The first figure is changes in temperatures under 2 extreme scenarios. Changes in rainfall pattern is the second figure. And the third figure is to basically look at the changes in extremes. Now, temperatures are definitely rising. As I said, rainfall is also increasing, if you see in the northern parts of India and South Asia. And the third figure is basically to say, so the 99th percentile of heavy precipitation event occurrence in this region is also going to increase. Now, what do you mean by the third figure, that the 99, increase in the 99th percentile of the rainfall basically means that it's going to be more rain in the form of heavy rains in many parts of this region, and therefore the concern is related to in what form and format this rain would fall, in which area, and whether this would lead to conditions of more flooding over future time periods, and basically asking for more preparedness towards such events, so that the losses resulting as a result of resulting due to this flooding is basically managed better. This is basically an assessment for the same region, which basically talks about changes in return periods of floods. And this slide basically says that depending on the scenario, which is the extreme scenario, the modest scenario, flood events are expected to increase by 40% to 110% in the upstream areas of the catchment that we see over here, and about 115% to 150% in the downstream areas of the river basins. And the river basins here that you see the figure is Indus, Ganga, and the Brahmaputra. And all these 3 river systems are parts of our northern and northeastern parts of our country. And therefore, we are saying that most of these river systems are likely to be basically experiencing high degree of flooding, both in the upstream areas as well as the downstream areas. Now, what does all this mean in terms of impacts? Now, according to me, if I just normally put it, it's going to affect everything under the sun. So all sectors are going to be affected, all ecological systems are going to be affected. If rain is going to change, your temperatures are going to rise, your humidity levels are going to, it's everything under the sun basically changing. So your agriculture, water resources, forest biodiversity, coastal regions likely to be affected, and their, the sectors within and the health sector basically are likely to get affected. Now, agriculture is basically going to be affected in the form of yields and production, and how yields and production would be affected. And there are direct impacts of climate change on agriculture. There are indirect impacts because of water scarcity, extremes, and change in incidence of pests and diseases. So a combination of all these impacts on agriculture has been studied by different scientists. The Indian Agricultural Research Institute has this figure for India, but it did some estimations to look at how rice, wheat, and mustard are going to get affected in different parts of the country. And these are statistics from them basically saying that irrigated rice, wheat, and mustard productions will be reduced to the tune of 6%, 4%, and 4% respectively. And therefore, saying that while there will be this reduction, one could look at adaptation options or strategies, measures that can be used to compensate for these losses that we may experience across the country. So we will be experiencing losses in relation to different crops that we are growing. One of the strongest reasons why agriculture in India is going to get affected is that we are already in the tropics and our temperatures are already high compared to the temperate regions or the polar regions. Now, most of the things that we are growing, in this region is already growing at a higher threshold level, higher temperatures, and higher, higher end of the spectrum of various parameters. Now, any rise further from that to a slighter increase to a higher increase would basically result in overall losses, and therefore one needs to see at what adaptation can be considered to be able to reduce the losses. So agriculture is definitely going to be affected in that way. Now, there's impact going to be felt on water resources. This is basically to do with the water availability in certain areas. It's also to do with the flooding that may get created and the drought-like conditions that may get created in different parts of the country. Sectoral impacts, largely in coastal areas, agriculture, as I just said, it could be because of loss in production, but in coastal areas, it could be because of loss of agricultural land also. Seawater intrusion, and saline water intrusion because of storms and cyclone incidences that you may observe in certain parts. Water resources getting contaminated by salinity levels because of this insurge. Fisheries getting affected because of loss of marine habitats. Settlements basically getting affected. People who would get dislocated in certain parts of the country, and of course land that would get lost. Infrastructure, if there's infrastructure that's along the coast, basically getting affected, whether we're talking about ports or the tourism activity that is getting affected, and human health, basically to do with the spread of disease vectors, and also rise in temperatures and uncomfortable levels, which may lead to heat wave conditions and effects on health. This is basically summarizing how sea level rise will be affecting millions of people across Southeast Asia and East Asia, because most of the countries are actually coastal in nature, and the number of people, about millions and millions of people, to be affected across different parts of the world. This is basically to say we are observing ocean acidification, and that's basically increasing with the rise in temperatures and the melting of the glaciers and the larger ice sheets and the dying of the coral reefs, as Divya was mentioning. The acidification of oceans is also changing with the rise, with all these linkages that we see, rise in temperatures. So pH levels are basically reducing. And as a result of that, the marine fish catch that we see in oceans has also been reducing. And it would have an impact on that over future time periods. Now, if it has been reducing and there would be an impact on marine fish catch, of course, there's a counter effect where now we have much well-equipped systems for fish catch, and like motorized boats, etc., that are being used to go far more deeper into the seas to be able to get a good catch of fish, to be able to and their livelihoods attached to it. The risk is on the part of the fishermen, who would have to basically go far more deeper into the seas to be able to get a better catch. This is basically a storm surge simulation model that has been used for the state of West Bengal. So while there are questions that we normally have, the sea level rise is just 0.8 meters, and maybe the implications of a 0.8 meter is not that high, but there are implications of a 0.8 meters also, which is to do with the other sectors of salinity intrusion, etc., and water resources that you're talking about, and loss of land. But also when this 0.8 meter gets combined with the storm surge or the cyclone incidence, the degree of inundation that it can cause to coastal areas is basically reflected in these slides. This is the Sundarbans area of West Bengal, which basically shows that with a rise in the sea level, along with the storm surge, the area of land that actually gets inundated, and large amounts of areas actually then go underwater for a certain period of time. So this is basically a study done by Terry, looking at the intensity of cyclones and how is that going to change for the coastline of West Bengal. We tried to look at both the Arabian Sea and the Bay of Bengal area, but what we've observed is, while the frequency of these events are not going to increase in the future, of course, the intensity of these cyclones are going to change in future time periods. So a depression is going to be experienced in the form of maybe a deep depression as a cyclonic storm, and a cyclonic storm as a severe cyclonic storm, and a severe cyclonic storm as a very severe cyclonic storm. So the intensities are changing. So if you were likely to experience a cyclonic storm, if we were in normal conditions, maybe now you will experience it in the form of a severe cyclonic storm and a very severe cyclonic storm, because of the rate of warming increasing, and therefore we should be prepared for more intense events in future. Basically assuming that the frequency is not going to change. So, but the nature of these events is definitely changing. This is basically to say that, of course, we have huge population living in the coastal areas, and therefore we are concerned about the population which are in the coastal areas and how they are likely to get affected. The health sector, of course, there are direct effects and indirect effects. Direct effects are due to heat waves and events like droughts and floods. Indirect effects are more due to transmission and distribution of vector-borne diseases, waterborne diseases, and water-related diseases. That we are likely to basically experience. This is an example of the spread of malaria. It was an assessment done by Terry for the state of Maharashtra. In a study we were doing for the state, where we basically looking at how transmission windows for malaria are likely to change in the state of Maharashtra over future time periods, basically to see how the disease is going to spread in over future periods. And what we basically see that a 6 to 8 month period is basically expanding now to 10 to 12, the entire year. Therefore, because of the increase in temperatures and the humidity levels in many parts of the country, the transmission window for the spread of malaria in Maharashtra, basically what we're observing, is going to increase. It's providing a conducive environment, the increase in temperatures and humidity levels, it's providing a conducive environment for the vector to spread and remain in a particular area for longer periods of time. And you may as well arrive at similar stories for other parts of the country as well if you do the assessments. This is basically to say the temperatures are rising, humidity levels are increasing, and therefore the heat indexing that is done to see the comfort levels of these rises to humans is basically increasing. The discomfort is increasing over time. And this is basically more from the Western world, actually, this kind of a chart which looks at the temperatures and the rise in humidity levels. And the orange color on the top basically highlights the dangerous zone in terms of a combination of temperature and humidity. Now, this may not be the same for India, because we already, it ends at 42 degrees. India experiences far higher temperatures and possibly humidity levels in different parts. We need a similar chart for India to see what our discomfort levels are and where is the dangerous line crossing for us to present discomfort to our people, wherein we will experience more heat-related mortality and morbidity, and therefore we need to identify corrective measures to be able to address that concern. It's not that we are not experiencing these heat waves right now. There are from all across the country, when we have extreme summers and heat wave conditions created, there are reports that we get to hear about, cases in Andhra Pradesh, cases in Orissa, cases in Bihar and other parts of the country where there have been direct deaths because of heat wave conditions that have been observed in the past many years. In conclusion, basically, the risks are there and they're here to stay, and it's good if we all realize that and take corrective measures to be able to address it. And therefore, there's a need to frame responses to the likely risks of climate change and adapt effectively. Now, adaptation is possible, but it's not a solution to everything, because you may be able to address certain degree of risk, but in certain cases, it's not possible to address all the losses or the risks that you're likely to experience. So there will be residual risks that will be left, but that is still fine than actually, basically bearing the entire losses or experiencing the entire risk. So adaptation becomes a necessity by all means, and therefore one needs to look at adaptation to be able to adjust to a certain degree to the risks that are likely to be experienced. Now, this requires mainstreaming into policy and planning, as Divya was also talking about in her slide. Now, what do we mean by mainstreaming and adaptation? Now, a lot of it is to do with what we already have in place, but basically we need to enhance it in a certain way or scale it up in a certain way to be able to give the right kind of benefits for adaptation. So looking at our current programs and schemes, policies that have the potential to contribute to adaptation and how they need to be scaled up to contribute to adaptation. On the other hand, we may totally not have programs in place that would be able to address certain kind of risk or risk that we are talking about. In that case, basically, we would need the development of new programs and schemes that will be required to be implemented. So therefore, the focus has to be on looking at new ways of development, although not entirely a novel one. But of course, we are not talking about a business as usual development pathway. We have to move away from the BAU development trajectories that we've drawn for ourselves. Adaptations of different kinds. It's anticipatory in nature. It's reactive. It's done through the public sector. It can be done by engaging the private sector in place. It's autonomous in nature and it's planned in nature. So now what do we mean by anticipatory, reactive, autonomous, planned, public, private? Public and private is largely the government or the private sector taking it forward, or maybe a combination of public-private sector. So public-private partnerships can be struck to be basically force in adaptation and implement things. Anticipatory is basically already assuming certain degree of changes in a certain direction, and therefore you're taking corrective measures. So it's more like preparedness. It could be basically reactive. So you've experienced a certain event and then you're responding to it, and therefore measures are taken later on to be able to put in corrective measures. Planned and autonomous. Autonomous is basically things are changing and people are responding to those changes. It's like being reactive. And an example of it is farmers actually. So the weather is already changing by various means in many parts of the country. We have not still taken the right kind of measures to them, the farmers, to be able to basically adapt to the changes that are basically being experienced, but the farmers are still doing some things on their own, and that's autonomous adaptation. Some things which may be helping them in terms of adjusting to the changes that they have so far been experiencing. Planned is more to do with the government and the private sector coming in and assisting in the implementation of the various measures that we are talking about. Of course, and this is the point I told before, that adaptation may help in many cases, but it may not reduce all losses. And therefore, we should keep that in mind when we are basically, but if you look at, if you have, this figure basically saying that when you have constant protection versus enhanced protection, the degree of change in terms of reduction to risk that is likely to be observed. This is basically saying that, so where do you need adaptation? Basically depends on where you are, who you are, and what you need to do about it. So basically, if you are in an area which is highly exposed to the risks of climate change, just next to the coastline, and infrastructure is built right near the coastline, which is highly exposed to the risk that we are likely to experience, then of course, you are highly impacted. You will be highly vulnerable to the impacts of climate change, and therefore, what needs to be done needs to be thought about. So this is something I've already said, that we will have to, and as a result, we will have to align our developmental activities. We may have to look at sectoral ways of basically adapting. We may also have to look at cross-sectoral ways of operating to be able to address some of these concerns, and a mix of existing and new measures that we may have to look at. This is basically to say that we have to look at the additionality component of the risk and not basically say look at what development we are doing. There are in certain cases where there are issues related to revenues and investments that need to be made in these conditions. The approaches that are broadly looked at are win-win opportunities that can be selected, wherein there's a convenient fit of the current intervention or action that is being proposed under adaptation in the scope of current development policy or program that is being run by the state or at the local level. Also looking at trade-offs between short-term costs and the long-term benefits of delivery of those actions that are basically implemented, and that looking at a whole range of things which are related to the scalability of those actions, the feasibility of those actions, the issue of equity and how that particular action would be able to target a whole range of stakeholders who are likely to get affected. So many things that need to be considered in adaptation, and while planning adaptation, is just a few points over here, basically driving home the fact that it's not easy to plan for adaptation. It's very difficult. It's too complex an area, but it needs to be done. And at least we have to start with it, because we all understand that the risks are huge. There are different modes of implementation considered, where you have to basically, so it cannot be done in isolation. It's basically to be done with all the stakeholders that matter with regard to a particular risk that they are exposed to, and the responses that are needed to be able to reduce the risk. So starting from the electoral representatives right down to the community level are people who have to engage in and show their interest in terms of getting this implemented and acted upon. So and this basically tells you the complexity of getting these measures implemented and embedded within country frameworks. This is just an example from a World Bank study we are doing in the state of Uttarakhand right now. The study is basically to mainstream climate and disaster risks into state policy and planning. It's not the state action plan. It's a study under their disaster recovery plan initiative of the World Bank. Now, to be able to do that, we did a thorough review of different areas that are exposed in that particular state to the risks of climate change. What is already being done, where are the gaps that are there in terms of addressing the risks, and then if there are gaps, what kind of actions need to be taken to be able to address those risks. So that's the proposed recommendation. And then, of course, the gaps come prior, and we're looking at the actions that need to. Now, once we've identified the action, in this case, it's the forest and biodiversity sector, where we're basically proposing the use of alternate energy in the case of the state, where the dependency on forests is high for fuel wood, and therefore and they have a lot of it's not plantations, but they have a lot of chirpine present in certain parts of the mountains, where there are issues related to the presence of chirpine. So therefore using that as and processing that in a way which can serve as alternative fuel to the state for cooking purposes, as well as for other, for electricity purposes. So basically suggesting that as an option. And so to be able to mainstream this particular recommendation that we were suggesting to the state, there was an exercise done to look at what are the existing state policies and schemes with which this particular recommendation basically matches. So that if in case we are short of revenues and investment is a concern, ideally we could place it into existing state policies and schemes that may be able to consider this particular recommendation, and we could leverage on it to introduce it within the state. So that's how the mainstreaming concept is being basically looked at in the context of the study we're doing. But this is another slide which basically says, normally when we look at the various gaps, the risks, the gaps, and the recommendations, we do arrive at a huge list of recommendations, interventions that need to be looked at. It's the case with the state action plans also. You may have some 40 to 80 or 100 actions being proposed, and ideally, people who are to take these actions forward get overwhelmed with the amount of actions that are basically being told to look at. So a prioritization exercise has been fitted into the current scope of work with the World Bank in the state of Uttarakhand. We're using MCDA and stakeholder consultative processes with this framework to basically look through each of the interventions that we are basically proposing to the state to get a score ranked by the stakeholders, both non-governmental, academia, civil society, and state government departments. And as a result of this ranking process and prioritization exercise, what we basically getting in the end is a descending order kind of a list of highly prioritized actions by stakeholders. And as you keep moving down, so of the 100 or the 60 odd interventions that have been proposed, we are able to now prioritize with the help of stakeholders some of these actions, and then basically discussing with the state that maybe it's not possible to look at the 100 actions, but the 10 actions which are on the top, which are prioritized, can we develop them into detailed roadmaps for mainstreaming it into state policy and action? This is an example of one of the prioritized actions which has come up through the consultative processes using this methodology, which has come up on the top, and a detailing of how then this particular intervention can be considered by the state to enroll it into its policy, enroll it into the state through its policy and planning. So there's a baseline of this particular action. There's a timeline given that up till 2025, these are the actions you can look at and enroll, because for one particular intervention also to be taken forward, there are n number of activities that need to first be taken into account before you can, over a period of time, successfully say that you have been able to, implement that particular action and therefore reduce the losses. So 20 to 2025, these are the steps for that particular action. 25 to 2030, and there's another column actually which looks at 2030 and beyond over the long run, how this particular intervention can be enrolled out and compared to the current status of looking at this action in the state. And we are looking at it with regard to 4 broad categories of, at the policy and governance level, what are the changes that are likely, that should be looked at financial level, what kind of support we are expecting at different stages, time periods when the intervention is being rolled out, fiscal reforms, and then institutional strengthening and capacities that may be needed to be able to achieve a successful implementation over time. So these are the kind of roadmaps now that are getting developed with each intervention measure, which is prioritized to be able to tell the government how they can consider it in their planning process to be able to mainstream it into policy, in their policy and planning. And I just wanted to leave you with this example. And I look forward to your questions and queries. Thank you.
Thank you, Dr. Sushri Balwal. Any participants have any questions?
I can see some questions for me, and I can answer them now.
Okay.
Is that okay?
There was 1 or 2 questions in the chat window.
Yeah, so should I take them up now?
Yeah, you can take it up.
Okay, so there was a question on storage. So yeah, I think storage is one thing which is still evolving. There has been very recently, I think just a few days back, a big project that has been awarded to Renew Power, which is the first round-the-clock hybrid project, renewables cum storage in India, which kind of shows that storage is coming of age. But of course, there are still some concerns with respect to storage. I think globally, lithium ion is at the forefront of development. But it's just like solar was at one time. I think this is an area where there is a lot of work happening, and the costs are expected to come down significantly, and many technology options are being explored. I think pumped storage remains the most established form of storage, and that is what is being used in other countries on a large scale. India has also got some potential for pumped storage, but in terms of battery storage, I think it is an area which is I think in the state of a lot of flux right now, and we can expect some real sharp price drops like we saw for solar. So that's where we are on storage. On the other question was on the link between coronavirus and climate change. Well, scientists are saying there is a link, and the link is that climate change is one of the exacerbators of habitat destruction, and we saw that in Suruchi's slide, how it is destroying and degrading many ecosystems, whether it is marine ecosystems or terrestrial ecosystems such as forests, and leading to their degradation. We've been seeing a lot of instances of forest fires this season. So, And coronavirus in turn has been very closely linked to habitat destruction. And to the extent that climate change is one of the reasons of habitat destruction that we are seeing, I think the two are very closely linked. It also shows that, we are living in a very complex web of life, which, is, if you go back to our scriptures, for instance, they lay a lot of emphasis on biodiversity. And I think the understanding there was very nuanced, that it's not just for a charitable cause, but also because our own existence is linked to in this whole web of life, to other species. And I think that is what this virus has taught us. And climate change is affecting this entire web, and the delicate balance that exists between different species. So definitely there is a link between climate change and the outbreak of zoonotic diseases, which are on the increase in the last few decades, as we've seen. Are there any other questions that we can take up? I would request to look at a recent study. These are all there on UNEP's website. There is one which is called the Emissions Gap report, which I refer to extensively in my presentation. And there is a least recent one on zoonotic diseases. And it's called Zoonotic Diseases, How Do We Break the Transmission? And this is also available on UNEP's website. And I would encourage you to, pick that up and take a look at it. And it, touches on a lot of issues around the relationship to biodiversity and climate change. Thank you. Yes, sir.
Mr. Kalamegam, good afternoon.
Good afternoon, sir.
Good afternoon, and thank you for inviting me on behalf of the department. Thank you. And I happened to come and join the presentation little late. Otherwise, later part of Divya's presentation and complete presentation, I could able to see. I have a couple of observations. One is now since the National Coastal Mission has to be funded at the central government level or at the UN or World Bank level, NCORE is coming up, but in that one of the major components should be National Coastal Mission across the state. All the coastal states and union territories should be taken up, and then only it will be a funding financial institutional mechanism will happen. That is one thing. And the second thing, UN or any other agency should seriously consider supporting capacity building in all the state government and union territories. Otherwise, it is very difficult for any department to carry out science and technology, environment, pollution control, and also the climate change activities, though all have to be synergized, the existing activity, but to coordinate and take the programs forward at the national level, at the systemic changes, the policy level. I seriously request the UN to look forward these two suggestions at all forums, whichever you are addressing. That is for UN. As far as for Terry and Kalamegam is concerned, I have a couple of level observations. When you are preparing and updating the state action plan at the local level, like that of Pondicherry, what I would suggest is some 6 or 7 sectors, priority sectors were there both in the slides of Divya as well as in Suruchi. Now basically concentrate and work on them, or otherwise one other alternative method what I have observed and we could able to do is take up the annual plan book of planning department and go scheme wise. When you are preparing along with Terry updating the climate change action plan at the local level to act upon, take the annual plan and scheme wise document of various departments of the government, and then suggest what are all the schemes, policy interventions, and at what level policy interventions are needed. For example, I will tell you, when we in Delhi, when we wanted green building to be adopted by all PWD construction agencies, what we did is we had stakeholder consultation meeting between PWD, CPWD, and all construction agencies, and then we arrived at item-wise cost for green building components, and we moved a cabinet note and got 7 to 10% escalation in cost in government projects. So that was a classical example that we did in PWD Delhi, so that we could be able to straight away implement green building in wherever the planning is done without going for escalation of cost and justification. In the cabinet note and the annexes of the cabinet note, we got this thing approved. So I had this thing in mind when I was at Pondicherry, but Pondicherry we were severely short of funds, so I did not take this up, so I know what has to be done. But like this, now if some funding is coming from external agencies and from the ministry, I think this kind of annual plan-wise activity can be taken up for effectively implementing the climate change action plan. This is for revising the action plan for Kalamegam and Terry. Thank you.
Thank you so much, sir. Thank you so much, sir. For other participants, I would like to introduce Dr. Dwarak Nath, who just spoke now. He was our former director of Pondicherry Department of Science, Technology and Environment and Puducherry Pollution Control Committee member secretary. He was with us for a period of 6 years in which he brought a lot of changes, and he was a person who was instrumental for the first state climate change action plan which was prepared for Puducherry. We thank you so much, sir, for being present here.
Thank you, sir. We've noted. Yeah.